Hello there, I'm Thomas. This is German-American pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, then coming back to Zurich International Airport, runway 14 for an Lszh localizer landing. So right now I'm in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing you the cockpit instruments, the displays and the functions of the Boeing 787-900 jet aircraft. I'm going to start with the primary flight display. The displays are the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft in 10,000 feet per minute, the vertical speed indicator, and you can also select the flight path angle in decrease from the autopilot flight director system panel. We have also the artificial horizon with the altitude indicator, the pitch ladder in decrease, the bank angle in decrease, the horizontal localizer and the vertical glide slope of the Lszh system, the instrument landing system that receives the radio frequency transmitted from the runway we're going to use for takeoff and for landing, and they are received from the onboard antennas of the aircraft and display the horizontal localizer, the vertical glide slope and the Lszh localizer crossbars in the primary flight display. So we have also, you can see, we're gonna use the runway 14 of the Zurich International Airport, Lszh, and we're gonna have the 136 degrees of magnetic north pole heading for alignment with the localizer. We have also the angle of attack of the aircraft as it flies. The flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the flight mode annunciator with the autopilot and the auto throttle. Later on, vertical navigation mode. We have also the HSI that displays the magnetic heading and track, the integrated display of the flight plan. Also, you can see we have the navigation display that displays the GPS position, inertial reference position of the aircraft, the magnetic north pole, the geographic north pole, the magnetic variation depending on where we are in the world. We have the terrain and weather reflections from the weather radar. You can see the red, green, yellow color over here of the terrain around you. Also, you can see the horizontal and vertical depiction of the terrain. So you have the horizontal here. You can see some airports here, our own airport also, where we are located. You can see the vertical, how far we're gonna be flying above the ground later when we're gonna be airborne. So we have the red, green, yellow, and also the blue for lakes and sea and rivers. You can see also the terrain map with the airports where they are located. Our own airport, the Zurich International Airport, the Lszh in Switzerland. We have also the work stations, ADFs and DBs, the waypoints which are horizontal and vertical navigation fixes. The aircraft will gonna have to fly through some waypoints. You're gonna see later. I'm gonna select some waypoints using the flight management computer and put when I'm gonna create the flight plan or flight path or route of the aircraft. We can follow either manually or automatically. You will see also autopilot flight director system panel, flight management computer down here, primary flight display with the HSI in the flight mode annunciator over here, the head-up display, the thrust levers down here. So you can see the thrust levers. You'll see how I can actuate the thrust here, commanded by the engine's thrust levers. So you can see the thrust increase or decrease like this. You can see also we have the flight controls here. We can control the flight controls of the Boeing 787. So we can climb, we can descend, we can make turns to the left, turns to the right like this using the control wheel. Also the elevator for climb and descent, the control column, or the rudder pedals for the vertical rudder. So I will show you the flight control surfaces and the flight control, also the axis of control, the aerodynamics of the aircraft, how we control all the flight controls, as you can see using this side stick here, the Logitech Extreme 3D. So we have the navigation display also. You will see later, I will explain later. I will start maybe with the flight controls. So in the navigation display we have also the display, as I told you, the flight plan. You can see also other aircraft that fly around us using the transponder, this being ADC transmitter receiver that transmits our frequency to other aircraft in the air traffic control and receives from other aircraft, and displays the other aircraft, the distance they are positioned, their altitude difference from our aircraft, whether they climb or descend with respect to our aircraft. Also, you can calculate the velocity closing in between our aircraft and the other aircraft. So you can calculate if we have an incoming collision in the air, will give us a warning. The TICA system, track collision advisory system, you can see displayed in the primary flight display, in the navigation display. So we're gonna have also the ACAS engine indication crawler system display. You'll see the engines indications down here. You can see the left engine and the right engine, what they display. As you can see, the N1 and 2 exhaust gas temperature. So we have N1, which is low speed starter start, low pressure compressor and turbofan good engine, exhaust gas temperature over here. N2, which is the high speed starter start, high pressure compressor and turbine of the turbofan engine. Fuel flow per engine per hour, 1000 kilograms, 1000 pounds, solid pressure, solid temperature, all quantity and vibration of the N2 stage of the engine. Pressurize, cabin pressurization here, cabin altitude, rate of climb and descent, differential pressure and landing altitude over here. The outflow valve you can control over here, as you can see. Cabin pressurization systems, you will see many systems. You see the electric system, the hydraulics, the fuel system, electronic engine control for the engines, with the auto start over here. You will see the fuel booster pumps and the fuel tanks. You will see the air data computers here, flight control computers, primary flight control computers here in the auto position. This is a fly-by-wire aircraft, so we have primary flight control computers to control the aircraft flight controls in flight. You will see also the APU. We're gonna start the engines using the APU. So you will see many systems here. I will show you the horizontal trim stabilizer over here, the speed brakes, the flight management computer. I will input all the data using the mouse pad here, as you can see. So we have the mouse control like this over here, as you can see. So this is also the flight controls and the mouse here of the aircraft for controlling the display here, as you can see, for making inputs of like this, so we can select from the flight management computer some modes. Later you will see how I'm gonna create a flight plan over here. Also using the keyboard here, we have the radio frequency receivers here, and Lszh localizer, navigation radios receiver, the transporter, radar stream, fire extinguishers for the left and the right engine, fuel control for the left and the right engine over here. So this is the radio management panel. We have also the flaps here. We'll see the flaps later. I can control all the flaps, retract or extend like this. Also the speed brakes. So you can see the flaps here with their position. They're fully extended right now, as you can see. Also the speed brakes. So you can see also the speed brakes extend, retract, actually extend. You can see the thrust levers. You can see the horizontal trim stabilizer here. You can trim the nose with the nose of the aircraft as we fly. Nose up this way, nose down. This is the alternate fly-by-wire channel. of the pitch trim, so you can pitch trim down the aircraft and pitch up as you fly by pitching up the elevator. As you can see, elevator trim, left click down, right click up. So this is pitch nose up, nose down. We have also the cutoff switch, I will talk to you about now. So you open up this and turn off from normal to cutoff later. This horizontal trim stabilizer of the aircraft. So we have the manual trim switch of the aircraft, horizontal trim stabilizer. Over here you can see this trim switch. So this way you trim up the elevator, you trim the nose up as you fly, you trim down the elevator, or the stabilizer, horizontal stabilizer, both of them, left and right. You can see elevator trim, left click down, right click up. So this way you trim up the elevator, this way you trim down, and you pitch the nose up or down as you wish when you fly. You can see we have also, so this is very important, we have the head up, the air switch, the flaps, limit speed, the autopilot disconnect over here, the control wheel over here, so use the control wheel also for islands and spoilers. As you're gonna see, elevator up and down, the whole elevator surface for climb descent as you fly. So we have a couple more minutes. I will show you also the autopilot flight director system panel, the functions. You can see we have autopilot engage, disengage, auto throttle left, right, the modes, LNAV, VNAV, flight level change, auto throttle climb continuous, flight director, airspeed, heading, bank angle, vertical rate of climb descent over here, and altitude. I will show you later how to use all of them. You can see 200, 360 and 10,000 are also displayed right now over here in the displays. 200 knots, 10,000 feet with purple, and 360 degrees the heading selected. So we're gonna change all these settings later. So you can see we have the horizontal trim stabilizer. We can trim the horizontal tail of the aircraft as we fly. So this is a fly-by-wire aircraft. We can also have the auto trim function for the horizontal tail trim stabilizer when we fly. So we have the flight control computers. We have the normal, the alternate, and the direct mode of the aircraft when we fly like this, as you can see. So we have over here the flight control computers in the auto position, primary flight control computers like in the Airbus pretty much. So you can trim itself by flying with the autopilot flight director system panel, the auto throttle, flight management computer inputs, and flight control computer inputs. You can trim the horizontal tail of the aircraft as you fly manually, or you can leave the auto trim function. So if you have a failure of the hydraulic system that affects the horizontal trim stabilizer, the left or the right, you can see the hydraulics over here, hydraulic pumps over here, engine driving and electric driving. We're gonna have a malfunction of the automatic trim function, so we have to come down here and open this guarded switch, red guarded switches for all Boeing 737, 747, 757, 767, 777 and Boeing 787. Open up and turn from normal to cutoff. Then you disconnect the auto trim automatically. You have no more automatic trim from the computers, so you have only the manual. You have the alternate channel over here for manual trimming with your fingers like this, nose up or nose down as you fly, or using you have also the parking brakes, not related to that, but you can use them as you can see over here. forgot to mention. So you have the manual trim switch all the time here to trim the horizontal tail as you fly. So this is the horizontal trim stabilizer. We're talking about Newton's physics, aeronautical and aerospace engineering, and flight aerodynamics, and also the Bernoulli theory of fluids. I will explain some principles we need to know when flying the aircraft, also the air transport pilot license. So you can see here we have the outside view of the aircraft. As you can see, the wings can hold the weight of the aircraft as the aircraft flight, mainly the forward wings. We have the aerodynamic chord position, the Mach pretty much about here, 23% of the aerodynamic chord position is where the maximum aerodynamic lift occurs in the forward wings. Also the position with the stall will begin when we fly. The airflow becomes detached all the way back from the top surface of the wings, and we gonna have the aircraft falling. So we need to pay attention here to monitor the stall speed here all the time. In the primary flight display you can see the airspeed indicated. I'll talk to you about now. Airspeed indicated. You have also the stall speed here below with a red and yellow indication. So we have also the thrust from the engines, the jet blast from the engines that propels the aircraft forward through the nose, exhaust nose of the engines. From the forward also fans, the compressed air. We have also we have the vectors from the engines that push the aircraft forward. We have also, as I told you, aerodynamic chord position, the center of pressure on top of the wings as we fly. We have the center of gravity, the vertical axis, which is also all the yawing axis. We can yaw the aircraft left to right using the rudder as we fly, as you can see. So this is the yawing axis through the center of gravity down here. Around it creates a moment that turns the aircraft in the air. We have also the lateral axis from wingtip to wingtip over here, which is the pitch axis. The pitch axis is the elevator like this. You can climb and you can descend the aircraft using the pitch axis over here. So you climb, you descend using the pitch axis here, the elevator for climb and for descent. As you can see, the horizontal tail of the aircraft. You have also the horizontal trim stabilizer, alright, so you can trim the elevator as you fly, or the stabilizer. So you have the elevator, the pitch axis, the yawing axis. We have also the longitudinal here from nose to tail, what transverses. The other axis is the roll axis. You can make left and right turns using the ailerons, the spoilers, and the flaperons. So you can see the yawing axis like this, left and right turn. So you can see the yawing, the roll axis, either one side or the other as we fly. So we have also a couple more things to know here. You can see we have the surface of the wings. The bottom surface of the wings is more flat. Also we have the flaps extended using the Bernoulli theory of fluids. As we fly we have also an angle of attack that usually is positive, so the airflow is moving slower below the wings, which creates a higher pressure below the wings, which pressurizes the aircraft wings and weight up into the air. Also the top surface of the wings, you can see the airflow is moving faster using the Bernoulli theory of fluids, so we have lower pressure, which sucks the aircraft wings and weight up into the air as we fly. So this is the aerodynamics of the aircraft that we need to know when flying, for controlling also the flight controls. I'll show you a little bit more of the flight controls now. So we use the elevator for climb descent. We need to pay attention also the airspeed always to be above the stall speed and the angle of attack. You can see also the vertical rate of climb descent of the aircraft over here, more detail. the primary flight display, vertical rate of climb descent. You can see how many feet per minute you can climb or descend. The barometric altitude you are located, the pitch of the aircraft as we fly, 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees, pitch up or pitch down. Also the bank roll as we fly. Fly mode consider over here. Autopilot, auto throttle, airspeed selected and altitude selected. You can see also the barometric, the radio altitude above the ground, and also the barometric pressure here, 29.92 inches of mercury in the radio minimum. So we have the barometric pressure setting. You can set the barometric pressure of the outside atmosphere, so you can have your barometric altitude correct here in inches of mercury, hectopascals. We have minimum radio, the plan rates, weather radar, traffic and terrain. Also on the display here you can see the terrain, traffic and weather radar. Cancel, accept, reject, some warnings over here. So we have also, I will show you later, the landing gear here, extend and retract, alternate gear, you can see here. Lock override, you can see the landing gear down right now. Auto brakes here. So I'm showing you the flight controls. We need a couple more things to see. So we climb over with the sun using the elevator like this, as you can see. Climb and descent. The pitch axis, the roll axis. Over here, left and right turns like this, the roll axis. And like this we have the rudder pedals, the yawing axis. So the yawing axis down here, the rudder, as you can see, and the elevator. So we have the full flight controls. You're gonna see later in flight. Also in the rudder pedals we have the nose wheel steering. The tail are interconnected with the rudder pedals. It can deflect the forward nose wheel of the aircraft. You can see the nose wheel down here. Over here is the nose wheel of the aircraft, you can see. So you can deflect the nose wheel like 76 degrees left and right until we reach an airspeed in takeoff like 45 knots. It decreases to 7 degrees left and right, 7.6. So you can use the rudder pedals to control it. Also after 45 knots it decreases all the way up to 76 knots to 0 degrees from 7 left and right, because we have the rudder. Also the vertical tail aerodynamically effective above 45 knots, so use the rudder for nose wheels for directional control left and right. So you have also the toe brakes in the top surface of the rudder pedals. So this is a few controls. You can see left and right captain and first officer move together. They're interconnected in flight. All flight controls move together. In the Boeing aircraft, or Boeing 787 in this case, when they don't move independently. Like in the Airbus you have the side stick priority for using either left or right side. So these move together. You can see side stick deflection proportional to the yoke deflection. Also I will show you one more view of the aircraft flight controls, then I will set up the flight management computer. So I'll show you now this view over here. So you will see also this view of the flight controls right now. So you can see also the side stick I'm using, as it's extreme 3D. As you can see I can climb and descend over here. As you can see, climb, I can descend. make turns to the left, make turns over here, left and right turns, climb and descend like this, and now the rudder pedals. So we have full control, also the horizontal trim stabilizer over here. Can you see side stick deflection proportional to the yoke deflection? You can see also we have the thrust levers over here, so you can control the thrust like this using the thrust levers. You can see how much percent we have the thrust lever set over here, forward or aft, using this thrust control here. Quite easy. So we have all the flight controls. Of the aircraft. I hope you like it. We can leave also neutral when flying the aircraft. I hope you like the Lszh Extreme 3D over here. So I will show you now the flight management computer and go to the rest of the systems of the aircraft. Hope you like the flight controls, also the outside view over here on this side. So you climb, descend, make turns left and right like this. So you have full flight control. So this is enough for the flight controls right now. We go to the rest of the system. So I will talk to you now about the flight management computer, how we can use the flight management computer to control. We're gonna create a flight plan or a flight path or a route for this aircraft, for this flight. So we'll input all the data of the aircraft for this flight. That includes the empty, the gross weight for takeoff. That includes the empty weight plus the passenger plus the cargo plus the fuel on board. Where the fuel is stored in the left and the right wing. In the center tank, the flight management computer is gonna calculate the center of gravity of the aircraft. Also, as we're gonna be flying, we have 30% in the left wing tank, 30% in the right wing tank, and 10% in the center tank. So the flight management computer is gonna calculate automatically as we fly the center of gravity of the aircraft. That will affect the horizontal trim stabilizer, the thrust commanded, flight management computer inputs also, and flight control computers, and FADEX control. The FADEX are the fuel authority. These are electronic control computers that control the engine's function. So we have all these things. We have the flight management computer is gonna calculate the center of gravity. Also, as we fly, we burn fuel, so the center of gravity is recalculated. Also, the mineral dynamic chord position, the Mach of the forward wings, which is 23% of the forward wings mineral dynamic chord position, with the maximum dynamic lift occurs in the forward wings. Also, with the stall, as I told you, the stall speed as we fly will be key. We have also the horizontal trim stabilizer of 4.25 degrees for takeoff. The runway we're gonna use with 15 degrees of flaps. The flight management computer is gonna calculate the runway length, the runway slope, the wind direction, speed, the barometric pressure, the density of the air, and the temperature of the air. Also, the runway conditions. If we decide dry weather, will give us the takeoff speed V1, we rotate in V2. So we'll have a rotate V2 like 130, 140 knots. I'm gonna use 9 degrees of pitch attitude for takeoff. Then we're gonna have also the seeds inserted in the flight management computer. The seeds are the standard instrument departure waypoints and fixes that include horizontal vertical navigation fixes and altitude and airspeed constraint. For the initial climb and departure of the aircraft, we're gonna have to cruise in this cruise level 25, 26, 27, 29, 28, 29, 30,000 feet above the sea level. We're gonna descend. We're gonna cross through some waypoints, make some turns, and we're gonna start the descent from the top of descent back to the airport elevation to about 7 or 6,000 feet above the sea level. We're gonna have the stars, the southern terminal arrival waypoints and fixes that include horizontal vertical navigation fixes and altitude and airspeed constraints. For the terminal approach and landing of the aircraft into the airport, the Zurich International Airport, Lszh in Switzerland. So we're gonna have again the Lszh localizer, the instrument landing system that will help us align the aircraft with the horizontal localizer and the vertical glide slope for approach and landing. We're gonna have this is what transmits radio frequencies, antennas from the runway threshold for the horizontal localizer and vertical glide slope alignment. We have the Lszh localizer purpose, and we have the radio frequency. We have the onboard antennas receivers on the aircraft for the Lszh localizer instrument landing system, and we have also we're gonna have 136 degrees the magnetic north pole heading fixed aligned with this runway localizer. We have also about 35-30 degrees of flat extended for approach and landing, and about 160-170 knots of airspeed and the landing gear down, and the pitch altitude of 9 degrees or less. So you will see the complete flight and flight plan of 5 alpha route we're gonna create using the flight management computer. And in the end part of the video, you'll see the complete flight from takeoff, climb, cruise, descent, approach, and landing. So I go right now over here to show you how I'm gonna use flight management computer to create the flight plan here. So we have control quadrant. You can see the mouse pad I'm gonna use here. You can see nice view here again of the cockpit. So we have here to input all the data we need. So we have identity, position, performance, takeoff, all the modes, approach, navigation data, flight plans, load the traffic control, route ATC route load plan, save plan. So we have identity, Boeing 787-900, GNX engine, save cycle over here, index, position, the reference airport. We can use that for inertial alignment of the iris of the inertial reference system, and the air data computers if we need. So we have the GPS position aligned. We have the performance. So we have zero fuel weight and fuel on board, cross weight for takeoff. We're gonna use this later. Reserves, cruising altitude, cost index, minimum fuel freezing temperature, and cruising center of gravity. So we're gonna have the calculations for that. So we have also, as you can see, reserves. We have the route departure from this origin airport, Lszh over here. So we use this for departure, Lszh, and copy paste again, Lszh, clear. Still gonna use 14 the runway for takeoff over here, route departure. So we use departure. We can select either runway over here. Runway 10, runway 14, 16, 28, 32, and the seats are the standard instrument departure waypoints and fixes that I told you. So we select runway 14, trans Zurich, the seats departure arrival again. So we have the arrival. You can select the approaches, VOM 1628, 34 ILS 14, ILS 16. Over here we have other runways, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we select ILS 14, trans Amity over here, and the stars is other terminal arrival waypoints and fixes. So we have Negria 1 Alpha. So we have the legs created. The route is displayed with blue here, is not yet active, and we don't have the purple. So we have the first, second, third, fourth waypoint to Zui. Then we climb over here. Next page, cruise level, descend over here, approach over here, start, and landing. So this is the flight plan not yet activated. We need to have zero fuel on board, cruising altitude 25,300 feet. Is gonna calculate the fuel burn cost index for this flight. Also fuel freezing temperature and center of gravity. So we can execute. Press this button now. We will activate the flight plan. You will see now with white and purple over here. So it's the active flight plan. First waypoint 136 degrees heading, 2 nautical miles, 324 knots, 1900 alpha. Second 1 nautical mile, 3 nautical miles, 5 intercept. Zui 0526 nautical miles, 324 6000 alpha. We change and we make a left turn here. Negria 36 nautical miles, Mach 0.567, flight level 25,326 nautical miles from Zui. 230 degrees, we make a right turn here. 12 nautical miles is the motive. Mach 0.76, 25,300, Amiki 6 nautical miles, 258 degrees. Descend here, approach, let's see the descend, 25,000, Zui 276, 9 nautical miles from Amiki, 187,000 alpha, 290 degrees here, 6 nautical miles, 186,000 alpha. TRA 180 knots, 5,000 alpha, 290 degrees, 235, 6 nautical miles, C1, CI 14, 108 knots, 4,000 alpha. This is the start of the terminal approach landing. 136 degrees, 5 nautical miles, 324 knots, 4,000, runway 14, 136 degrees. This is the runway heading, 8 nautical miles, 140, 1,400. So we have the flaps set, 15 degrees center of gravity, and trim 4.35 degrees, and the takeoff speeds V1, V-rotate, and V2 with this gross weight over here. So we have the index, all the performance over here, route, departure, arrival, alternate VNAV, progress, FMC communication, hold. We can select a waypoint to hold in flight, make turns, the fix, we can set wings. Also we have the navigation radio to ILS, for instance. So we have the initialize again, legs, go over here, virtual cockpit. So we have the virtual cockpit again, a few more things to see, thrust levers, flap, speed brakes, overhead panel. So we have again, as you can see, we have the flight plan displayed here in the HSI, as you can see, with purple, from takeoff, climb, cruise, descent, approach, and landing here, the ADF left and right. You can see the navigation display that displays the air data computer input. So we have the airports here, is Germany, France, and Switzerland over here. You can see how far above the ground we will be flying later. We can select our higher altitude, also the waypoints we have to cross through. So this is also the flight plan, the review of that from takeoff here, the runway is for takeoff. Also the center display over here. So this is the takeoff route over here from the runway, the climb, the terrain elevation. You can see also we have some terrain in front of us right now. You will see some yellow, red, and green indications depending on the altitude difference. Look further away over here, Amiki, Negria. So this is the further away we can see. Also use standard again. If we look closer, you'll see the runway also displayed and the terrain, as you can see. So we have the runway heading here, the taxiway we are right now parked, the other runway. the terrain in front of us, the elevation. So if we look in front of us, this is the taxiway we have from the GPS here. This is the runway we use for takeoff and for landing. The other runway just like in the outside view, the terrain also. So everything is correct. As you can see in the GPS positions and display. So we can look further. We have also the plan, this view over here. So this view of the plan, map setting, terrain, elevation. Climb over here, cruise, descent, approach and landing, make some turns. So this is FIR airspace, the engines indication, we're gonna have it now. So we're gonna set the autopilot flight director system panel now. We need for this flight also, so we have the airspeed selected, autopilot engage, disengage over here. As you can see, auto throttle left and right, engage, disengage, flight director here, LNAV and VNAV, select, deselect, turning off the flight director, deselect the commanded modes. We can have only the flight director on, we can turn them on. The airspeed we can set over here as we wish. So we have flight level change, climb continuous, auto throttle, autopilot disengage like this. The bank angle limit. Also heading select, we're gonna select the heading of the runway over here. Altitude also, this is the altitude guidance, we can select whatever altitude we wish to fly over here. So we have 35,000 and 300, the vertical speed. Over here, zeros, descent over here, or climb, as you can see. These are the climb rate like this, how many feet per minute, thousands, 3,500. So we set also for localizer approach for autoland over here. We have a couple more things to see. The thrust levers, the indications are correct. You can see the thrust levers display. As I told you, the N1, which is low speed starts low pressure compressor, into one turbofan with engine exhaust gas temperature, into which is high speed starts high pressure compressor, into one turbofan with engine fuel flow, parents power, oil pressure, temperature, quantity, pressurizer, cabin pressurization here, alpha valves. You will see the indications also. So we have the FAREX over here. The FAREX are the full authority digital. The FAREX are the full authority digital electronic control computers, one installed per engine gearbox, dual channel redundancy. If one channel fails, the other takes over. Controls modules displays all the engine data, showing the ACAS, engine case control system display. All multifunction display like the N1, which is low speed light pressure compressor into turbocharged engine, and 2, which is a high speed starters high pressure compressor into one of the turbofan engine, exhaust gas temperature, fuel flow per engine per hour, 1000 kg. So also the FAREX control the outflow valve from the pressurizer that supplies with pressurizer from the 5th and 9th stage of the engine. High pressure, low pressure compressors, so you can supply with pressurizer, cabin pressurization, oxygen regulation in flight, air conditioning ventilation, engine, wing and engine anti-ice, hot air for wing and engine anti-ice, and also the hydraulic fluid tanks pressurization. Also we have the bleeder from the bypass fans. So we have also, as we fly higher, the aircraft with higher altitudes, like 20, 30, 40,000 feet above the sea level. As we climb higher, like 8,000, 9,000, 10,000, 11, 12,000 meters above the sea level, the pressure of the air, the density, and the oxygen level become less than half than that of the sea level. Also, pressure, oxygen, and density. Also, the temperature of the air becomes freezing, like minus 30, minus 40, minus 50, minus 60 degrees below 0 Celsius. Also, the aircraft will be flying at an airspeed rate like 2 or 3 times faster than that of the sea level, so we're gonna have a higher intake of air from the front fans as we fly higher and faster. So we're gonna have a different fuel mixture adjusted every second automatically from the FAREX control, the full authorities electronic control computers. Also, as we descend back to the airport from the cruise level, so we continue to have the FAREX also control the recirculation of fuel as we fly into freezing, like minus 37 degrees. The fuel will be freezing, so we recirculate the fuel automatically from the left and right wing tank and the center tank to the engines components to heat up the fuel to the turbojet jet engines components. Also, we do the same for the lubricant and the oil. So this is a few functions of the FAREX. Also, the pressurized hydraulic fluid as we move the flight controls. It pressurizes the hydraulic fluid tanks over here. So we have flight controls, which is flight by wire actually, is controlled by the flight control computer. So we have here, I will show you now. We need to start the engines, APU in the on start position. We have also this light. So this is the left and right IDG, the great drive generator, the contactors, 130 to 100 volts, 400 Hz frequency battery, primary flight control computers over here in the auto position, air data, computer here alignment of the aircraft, flight control surfaces, FD door, towing power, oxygen, passenger oxygen, window heat, rammer turbine, left and right engine, driving, hydraulics, pumps, demand and primary, turn off, we see what happens, turn on again, then to the auto position, we have electric also and the rammer turbine. So we have also the recorders, we have the cargo and APU fire, we have the electronic engine control for the engine with the auto start over here, normal and alternate mode for the engines, fuel gauge, so we can dump some fuel, select the nozzles and how much to remain to lose weight. We have the left and the right wing fuel tank, the center tank over here, the fuel booster pumps, the crossfeed valve is off, we turn it off, it on, you can feed either engine with either pump or either tank and balance the fuel between the left and the right wing, as you can see. So we have also the wing and engine guides here, cabin pressurization. So this is the pressurizer section from the left and right engine, APU, also oxygen regulation, cabin pressurization, fuel valves in the manual we use, also we can use in the auto position. We don't need to do anything in the auto position. So we have pressurizer also and electric power from the APU to start the engines. And one last thing to see before starting the engines, over here, so we have the digital format of all the systems, hydraulic APUs running, oxygen, liquid cooling over here, electric, you can see left and right engine drive and IDG, 120 to 100, 400 Hz, 120 to 100 volts, APU generators running, load set over here, and the main battery and APU battery, volts and amperage, 31, 38, hydraulics, left and right engine driving, electric C1, C2, where the hydraulic fluid goes with system, using how much hydraulic fluid pressure you have here, 5000 psi, it's left, right, inside the system, how much quantity, shut off valve, fuel, left and right wing, fuel tank, center tank, you can see low and high pressure fuel valves, left and right, center tank, also left and right wing, the crossfeed valve is off, but if we turn it on, can feed either engine with either pump or either tank and balance the fuel between the left and right wing. The APU fed from the left wing is this motor. The minimum fuel temperature down here, below which the fuel will freeze in flight, minus 37 degrees, so we circulate the fuel to heat it up automatically with the FAREX. So we have also the air pressurizer from left and right engine, the packs, oxygen, the doors are closed, the cabin can be pressurized, the landing gear, nozzle and landing gear, pressure of the tires and temperature of the brakes, flight controls over here. We move the flight controls like this, as you see. around, and we have the display of the flight control system, how many degrees. They can externally track the tail, also the rudder, horizontal stabilizer, FS display, maintenance, digital maintenance, and circuit breakers. So we have also systems review checklist, the checklist normal menu, what you do before start takeoff, after start, after descent, approach, and landing. So this is all we need. Also, we need to start the engines, so we turn off both engines fuel control. As you can see, fuel control in the off position like this, both engine fuel control. You will see what happens over here. The engines are off. So we go up here, you will see so we need to restart the engines. Hydraulics are off, so we go over here the panel, auto start in the on position. We have the APU admit pressurizer, so we see reconfiguration in the overhead panel. You can see the engines are off, both left and right. The systems, so we have only pressurizer. This stage is supplied with pressurizer above 20%, and 2 we can admit, you can hear the pressurizer right now. We can admit the fuel right now over here, left and right. Fuel very quickly, auto start on over here. So we have the auto start is supplying the engine with pressurizer and with fuel right now, and monitors the engine's data. So we have the engines almost start. We have the systems off, and the auto start here 62%, both engines running. We can go for takeoff, flaps for takeoff here set, speed brakes off, parking brakes off. So we take the air traffic control clearance and taxi to the runway over here. A bit more idle thrust. So we need to align now with the runway shading over here. As you can see, we have the tiller here for alignment. So we advance the thrust levers to full takeoff power over here, as you can see. Align now with the rudder pedals. So this is the takeoff. Roll, press the yoke a little bit down, a little bit left rudder. So we have 80 knots, 100 knots, 120, V1, we rotate slightly, like 9 degrees, as you can see. So we have positive attitude, and climb, takeoff, landing gear up. So you can see after takeoff we can leave the hands off the yoke if we need. There is no problem, the aircraft keeps climbing by itself. We need to press it down a little bit sometimes. So you can see the data here. We have the airspeed is 185 knots right now. We are 2,300, 2,400 above the ground, about 4,000 feet above the sea. The stall speed here, red and yellow. You can see the wind direction and speed, the flight plan. We have the terrain around us. We climb with 5,000 feet per minute, the pitch altitude of the aircraft. So we have also here, you can see how far above the ground we are, like 3,000 or 4,000 feet. You can see the terrain with green, some mountains also around you. The engines also, the indications, we keep climbing. So you see also red, green, yellow over here, indications. of the terrain. Also a little closer, the flight one. So we need to make a turn right now. You'll see a bit outside view. So you can see the lakes, the Switzerland over here, very beautiful view, and the airport as we depart. So we're gonna make a turn here. As we keep climbing, make a turn. Positive rate of climb over here. Keep climbing. You can see we can leave the hands off, there is no problem. We just need to make small corrections of the trajectory of the aircraft as we fly. So maybe a little bit closer over here. Also a nicer view over here, as you can see. So here we are, make a turn, leveling off. This is a wonderful view of the aircraft as we fly. So we're gonna cross through the Germany, the France over here, as you can see. We're gonna have some very nice views. Make left turn now over here. So we're gonna make a right turn in a couple of minutes. We need to cross through this waypoint here, Zui, as you can see. So we have the whole flight plan now displayed here. We're gonna be flying. Make a turn again. As we keep climbing, you can see also. So this is the view of the Boeing 787 after takeoff. Hope you like it. And we need like 12 more minutes for this flight to complete. So we have the Zui now over here displayed. We need to reach this waypoint. The airspeed also, the altitude that we're flying, the stall speed with the yellow and red, the wind over here. You can see the wind direction and speed. So we're gonna have the nigria now, it's 36 nautical miles. So make a turn here for the nigria. Realign again. So I hope you like this view of the cockpit as we're flying right now. A little bit pitch up altitude. And we need about 12 more minutes for the flight to complete. So keep flying. 21,000 feet over here. So we are here. You can see again a magnificent view of the galaxy, the lake, the Germany, my homeland, in front of you, the Bayern Munich, and the France, the galaxy again. So I'm gonna make a turn now for going back to the airport. So here's the turn over here. Make the turn, going back to the airport. You can see the turn. We can leave the hands off. There is no problem, no difference. We just give an input to the aircraft flight control computers. It's managed with the auto coordination, auto trim system, automatic trim. We can trim also by ourselves. We need a little bit more thrust. You can see how we take the turn here. We need a little bit right rudder also as we turn. So this is over here, overflying. We have the chemtrails already, the frozen vapors, as we are overflying here the France, the Germany, the Italy in this side, the Switzerland, and the Swiss Alps, and now the lakes. So keep climbing, almost. We need a few more minutes. So this is a better view as we fly of the aircraft. So need to align here, as you can see. "35,000 feet, we can level off here. And we have 9 more minutes to reach. So we leave the thrust at about 90% to accelerate. As we keep moving, we're leveling off here, you can see. So we need to follow also the flight plan here, as you can see. The thrust, the flight plan. So we increase the airspeed now, and we have a few more minutes to go. So you see where we are right now. We're flying 35,000 feet, 100, as you can see. So here we are, and we have a few more minutes to go to the airport. As you can see, we are overflying the lakes here, the Germany, Switzerland, the France over here, and the galactic view. So we need to start the descent now, as we are going back to the airport. So we go in here for approach and landing, as you can see. And we have 6 more minutes left. Speed brakes down, a bit more thrust, commanded, as you can see. So we keep descending here. We descend now from the cruising altitude. Have 6 more minutes to go. So keep descent over here. I will thrust also. A nicer view of the cockpit. So we need to start the turn over here, as you can see, for the descent to the airport elevation. Have 5 more minutes left, so we have enough time. A little bit more overspeed right now. So we have 4 more minutes. Need to start the turn here. So we keep descending, idle fast, and we have here the turn, as you can see, approach and landing. We need to align now with the heading here, as you can see, and we have 3 more minutes left for approach and landing. As you can see, we need to align with this heading over here. These waypoints for approach. So we are here, aligned with the runway, heading over here. Gonna have the Lszh localizer also, and have about 3 more minutes left. I'm gonna be approached and land like this. As you can see, we have 2 more minutes left. So this is approach and landing over here, and we have 2 more minutes, enough time. We have some wind gusts over here, wind gusts and side wind, crosswind component we need to align the aircraft from time to time on the side wing. Full flaps over here, set for landing, as you can see. So we have also the Lszh localizer here, the navigation of the Lszh localizer, whatever we need. So we align again with the runway setting, and we have one more minute for approach and landing. Few more airspeed and it picks up. So we align, we have some side wind, rudder pedals, ailerons and spoilers for alignment. With the runway center line because we have side wind and wind gusts also. So we need also to decrease the altitude, increase the rate of descent, have a couple of more seconds for approach and landing here. So here we are, aligned with the flare. Here's the flare of the aircraft, as you can see. So we flare and touchdown, very beautiful. Flare and touchdown, very smooth. As you can see, parking brakes, idle thrust and thrust reverse over here. So we align with the center line again of the runway, and we are slowing down right now. It's slowing. You can see we are in a perfect position over here, or our landing gear, the nose wheel. There is no breakage of the nose wheel or the landing gear. Everything is perfect. You can see we have the thrust reverse here.